Welcome, everybody. Tonight we're going to be working on our Python review homework. This is part of our Unit 8 homework, which is basically to complete these 6 programs to kind of refresh and review some of your Python skills that you learned in the Python class by writing a few different types of programs here. And the homework does include this document with instructions and some sample output screens. And you don't have to follow this exactly, so it is open to interpretation somewhat. But I'm going to try to do a solution that matches this output screen, somewhat closely is my goal. All right, so I'm going to start with this baseball simulator. And you can see the goal here is to use a while loop in the program, which we will do, but I'll also sneak in a for loop, which you guys will see. But a while loop, if you guys remember, is a kind of loop that allows us to test a condition, like an if statement, right? Test something for true or false. And then if it's true, we keep running the loop. And if it's false, the loop stops running. All right. So here we're told to use a random number generator. And the section 4.9.1 refers to your old Python book if you don't remember how to do that. But folks, you can Google this. You can just go to Google and say, how do I do a random number generator in Python? And you will get an answer. And we want to simulate the batting of one team. Just like a regular game, they get 3 outs to get as many hits and or home runs as possible. So we're going to keep track of how many outs, how many hits, and home runs. And I want you to look at even how the information is structured, right? So zeros are outs, 1 is hit, 2 is home run. So when batter 1 comes up and it says 2, they got a hit. When batter 2 comes up and they got a 1, and actually I'm saying that backwards. 2 was a home run, 1 was a hit, and 0 is an out, right? And in reality, we're going to make them equally likely to happen, which is not real, right? A home run would happen very seldomly in baseball, but you know what? We're just doing a goofy little simulator to kind of have you think about these loops and the kind of decisions that go with it. All right, I'm going to go ahead and dig into coding this. I decided tonight, instead of using Spider or Jupyter Notebook, I thought, you know what, I'm going to use Visual Studio Code just because I know some of you are curious about doing Python coding in this product. So the one thing I will tell you is if you do use Visual Studio Code, you do need to have your Python libraries installed. So if you've done the Python class, they're already there. But there's also a whole bunch of extensions that you can add that are Python specific in this platform. And I just want to show you a whole bunch of them. And notice all the ones that say installed are ones I don't have installed. But I do have the standard Python extensions, which Microsoft recommends. I have the Python debugger from Microsoft and the language support, which does kind of like IntelliSense and stuff like that. If you guys are using Spider or Jupyter Notebook, the coding is identical. I'm just showing you that Python is a language that doesn't care how it's written, right? Doesn't matter what tool you're using. A lot of the professional Python programmers that I've talked to that work out in the field prefer to use PyCharm by JetBrains as kind of like a general rule if they're doing general Python coding. And if they're doing data science, they tend to use the Jupyter Notebook. It's one of those 2 products. A lot of people have been switching over to Visual Studio Code, though, because of its extensibility, and people like the interface, so I'm kind of demonstrating it for that purpose. This is a free product from Microsoft. There's no cost to it. The moment you create a Python file with a .py extension and go to save it, the IDE itself will ask you to install the recommended set of Python tools, and you just say, yeah, sure. Click OK, and it'll do it. So I'm just putting it all out there so you know that. Python libraries are required. I think my machine's on maybe 3.12 or something like that for Python. What I am going to do, though, is I am going to let's see, open a folder here. So I need a spot to put my work. So always start with file management whenever you're coding. And this is, kind of like a strong recommendation no matter what you're doing. So I'm just bringing my file explorer over here. Let's bring the whole window over. And I tend to put everything on my Google Drive, and you guys can have your own storage approach. But I do have a folder for spring of 2025, and we are working on Unit 8. I might do a little amendment to that because I want to know this is Python code. Everything else is Excel. That's why I'm doing that. But I'm going to put all my work there. So now that I have the folder, I'm going to go ahead and open it. So I'm going to navigate to that same spot in my file system. And I realize I'm going quick, but you guys should have your own working paradigm for where you store your files, right? It's kind of one of the expectations of an IT person is to know where your files are located. It's a really fundamental skill. So don't neglect it, basically, is what I'm telling you. All right, so now I'm attached to that folder. Sure, I trust the authors because it's me. Yes, I trust the authors. And I'm going to get rid of the welcome screen. I'm going to go ahead and create a new file, right? So whatever your IDE requires for you to create a new file. And I'm just going to call this one baseball, I think, this time. Or how about baseball simulator? And .py. Okay. I do know I need to use a random number generator, right? If you guys read up on how to do that, you have to import the random library. The easiest way to do it is just to say import random. You bring in all the tools, but we're probably just going to generate integers, but that's a really simple way to do it. Another approach that I'm going to use, and I'm kind of doing this to kind of reinforce some concepts, mind you. I could just write the program directly on the root level. So in other words, without functions or a main method or anything like that. Last time we did this one, I did create a function called baseball game. So notice the parentheses and the colon. And then I'm going to put in this statement. And I didn't really teach you guys about this in the first Python class, but when you create a function and you don't have any code to put in it yet, you can type in this keyword called pass. So it doesn't underline and throw errors. So it just says, well, you're going to use this, but for right now, pass over it. Right. And I'm doing that on purpose. I want to go back out to the margin now, and then I want to call baseball game as a function so it runs. Right. So this is kind of in lieu of doing a main function, right? And if you guys had class with me, I talked about doing that. This is not an obligation. This is just the approach I used. Right? It's also kind of a way to teach you about this statement. So like one way that we sometimes build programs is we'll build programs and we'll maybe even build a menu for the program or all the different things you want to do within it. Like I want a function that does this and a function that does that and a function that does this. And, you give them names that mean things. And it's not a bad idea to pre-build what we call the stub of the function and put in the keyword of pass just so you have it ready to go. And it keeps other errors from happening in your program, basically. Right. But now that I'm thinking about the stuff that I do want to put in here, I know that I want to keep track of how many outs there are. So I'm going to come up with a variable called outs. I'm going to put 0 in it, right? We're going to start with 0 outs. And then I'm also going to have total hits, also set to 0, and total home runs. All of them set to 0. Now, we just put a variable up on the screen, right? And remember in Python doesn't ask you to declare the data type of a variable. The data type of the variable is determined by what you put in it. Right now, I put the number 0 in it. By default, that could be either a floating point number or an integer, but right now it looks like an integer. What makes sense? integers make sense for this generally. All right. Next thing that I'm going to do is I'm going to create another variable called batters. And for batters, I want a list of all the batters that are playing. So you could, if you want, you could give them names, but I said the word list. And if I wanted, for example, to create a blank list, I just use square brackets, right? What is a list in Python? A list in Python is where we have one named variable with multiple storage locations. Each storage location has an index number starting at the number 0 and increments by 1 each time. Now, if you had like real names to put in here, you could put in like, Joe DiMaggio or, Hank Aaron or whatever, right? But I don't, so I'm just going to come up with really simple like batter 1. These are coming in as strings, batter 2. And I'm not sure how many batters I should have, but I do want to make sure they're all strings. Maybe 5 batters is reasonable. Notice how each list item is separated by a comma. The other thing that you may or may not recall about list structures in Python is the data that you insert into a list. Unlike other languages, and I emphasize that, you can mix data types. If I was doing this in Java and I created a list or an array, I would have to declare what kind of data goes into it. Integer, floating point number, string, object, whatever that is. And then I would only be able to put that type of thing in there. In a Python list, if I wanted to add, a floating point number and then an integer and then a Boolean and then an object named car, whatever, I could do all of that. It doesn't really matter in Python. But I am being consistent. These are basically, in place of batters' names. So this is a list of batters, right? This is batter position 0, batter position 1, 2, 3, 4. The list is 5 in length. The highest index number is 4. The lowest one is 0. All right, so a little bit of a review of what a list is. Interestingly, I could make this a tuple. If you guys remember that funny word. Oops, yeah, I didn't want to delete all that. I just want to delete that extra thing by just switching these to parentheses. A tuple operates almost identically like a list. There's one big difference though. The difference is a tuple, I cannot change the contents. I can't add to them. I can't remove. I can't alter them. With a list, however, a list is allowed to mute or to be mutable, right? So that's what we call it. So a tuple is just like a list, but it's immutable, unchangeable. But a list can be changed. I can add stuff to it, remove stuff, change the contents, move stuff around, everything. I can do anything I want to it. All right. The next thing that I want to do is I want to create a data structure that's going to hold the results for each batter. So in other words, I want to keep track of how many hits I have per batter. And you know what? A good way to do that might be what we call a dictionary. All right, so I'm going to create first a variable, and I'm going to call it hits, per batter. Right. If you remember, a dictionary is defined by curly brackets. And if you guys didn't do anything like this, please don't freak out. It doesn't mean your homework is wrong. It probably still works just fine. This is just how I chose to do it, and also to make some points about some of the things that we learned about. But for example, if I wanted to take, let's say for a particular batter and track his hits, right? I might use a key value pair. So dictionaries hold key value pairs. That's the big takeaway here. Key value pairs kind of look like this. I might, for example, have the key might be batter and then the value might be 3. And maybe it would be better as like batter 1, batter 2, or something like that. But this part of a dictionary entry is the key in place of the index number. This part is the value that's stored with that key. If I had multiple values, I comma separate them. So multiple key value pairs. The curly brackets indicate that we're working with a dictionary. Now, I'm going to do something kind of weird. And this is, we're supposed to do a while loop, which I'm going to get to here in a moment. But I'm going to have this auto-generate some of the content inside of it. This is kind of weird, by putting a for loop in the dictionary definition. And you guys are like, what are you talking about, right? And so I'm going to show you, I'm just going to type it out and show you what I'm shooting for. And then I'll explain why I'm doing it, and then maybe it'll resonate with you, I'm hoping. And if not, then I'll have to explain it more, but that's okay. And so what I did here is I dropped a for loop into one part of the dictionary. What if I just take that for loop as it sits? What would this for loop do? Well, okay, let's read what it says. For batter in batters. So batters, we know, is this list. So basically, this is just a variable name I'm coming up with. I could call it, whatever, or letter B or something like that. We called it batter singular. So for each batter in the batters list is what this says, right? We're going to insert a 0, because how many hits does each batter have when they start? None. So I'm pre-generating a dictionary that's the key is going to be the batter name. That's going to go here, right? That matches that variable name. And a 0 is going to go in the value. So I'm going to basically end up with, to show you what it looks like in the aftermath, it'll be like batter 1 colon 0 comma batter 2 colon 0 comma etc. So each batter will get added to the dictionary. Their name is the key. How many hits they have is the value. This is just a faster way to create this list with all the batters, as opposed to typing it out manually. That's what I'm doing, right? So not really a big deal with 5 batters, but what if it was 100 batters? Wouldn't that be a lot easier? Especially if you had a list of names of batters. Yeah, it'd totally be easier, right? So that's just kind of my example of what that's generating. So you can just put a comment mark in front of that. All right, so that's going to build that list for me. And now I'm going to create another dictionary called outcomes. And this one is going to give me that list that we saw in the output. So for example, if the random number generator generates a 0, then that's an out. So the value that goes with it is out. If the random number generator generates a 1, that one is a hit. And if the random number generator generates a 2, we'll call that a home run. Now, obviously, like if you know baseball, you can have foul balls, you can have, it's a ball, a strike, a hit, whatever. You can have all this other, you could have like, I don't know, 30 different scenarios that happen. We're just trying to make it really simple, just those 3 things, right? Right. So we're building this into a dictionary, and then every time the random number generator runs, it'll look at the dictionary and then pull the value out that matches the random number. So it'll run and go out. You won't necessarily see the mechanics of it in the same way. All right. So there's kind of my data structures to begin with. And you know what? This one, that's a comment here. I'm just going to put back here just to tidy up the space a little bit. Another thing, and I don't know if you guys caught that, but like I deleted a line and I moved the other one up. And Python is one of those languages, we don't use curly brackets and semicolons in this language, but whenever we're inside of a block of code and a function is a named block of code, the indenting on it has to be consistent, right? You guys remember that rule? Maybe, maybe not, right? This one's off by one space and look, it's underlining red. So all the indenting, whatever that amount is consistent. Most Python IDEs will indent 4 spaces, but I think it can be as few as 2 or as many as 10 or something weird like that. But I think 4 and 5 are probably the most common. All right, now we're going to go into our while loop. All right. So how long does a team stay at bat? As long as the outs are less than 3. Right? If they get 3 outs, yeah, they're not playing anymore. They're not playing that inning anymore. All right. So now I'm going into my while loop. Now we got to think about what's going to happen. So a team comes up to bat. What happens? Okay, well, who's batting? Like, who's the next batter? That's how baseball works. So I'm going to create a variable called current batter. And now we're going to run our random number generator. And I want you to notice how we're going to do this. This is kind of a different approach than what we've used in the past. In the past, if you looked at any of your random number homework, you would run random, you would generate an integer. The integer would be from 0 to whatever number you chose, and then usually you'd add 1 to it so it'd match up with the 1, 2, or 3 or whatever. But I can also do this. I can say random. This is a little bit different approach, and I'm going to say dot choice batters. Now, this is different. This is a different approach to one that we've learned in the previous class. So, I'm I'm hoping you guys are with me on this. But what this allows me to do is the random generator can choose one of the objects that's listed in this data structure as its random choice. I don't have to like say integer or string or object or anything like that. So it's going to go into this data structure and it's going to randomly pick a batter. Okay. All right. Then we need an outcome from that batter. So here's where we're going to use the random integer generator because now we do need a number to work with. So I'm going to call the random function again. This time we're going to call rand int. And this is what we did in the Python class, if you remember. And I wanted to generate a value, right? And notice how I named this singular and that one plural. I wanted to choose 0, 1, or 2 from that list, basically. And so I'm going to have it choose a number between 0 and 2. If these were numbered 1, 2, 3, then I would add 1 to it, right? But they're not, so I'm not going to. All right. Then I'm going to create another variable called result, singular. And now I'm going to call that data structure from above outcomes. And this is a dictionary. And even though it's a dictionary, I still use square brackets to pick out the values inside the dictionary. And when I'm calling out values from a dictionary, I call the key, which is the first thing in front of the colon. And you know what? What key am I looking for? Well, the one that the random number generator just generated. So it's the singular outcome, whatever number that is, 0, 1, or 2, is going to go up here. It's going to look it up in outcomes. That value, or let's say, so it generates a 0, it's going to find 0. It's going to bring that and drop it into this spot, and then that goes into result. You with me? Yes, no, maybe? Okay. All right. And once again, I'm just going to reiterate, if you did it differently, it's okay. I'm just showing you the way that I did it. And mine has purpose behind it, which is I want to reinforce a bunch of concepts in Python at the same time. All right. So now we're going to do the output that's going to kind of match what's on the screen. So we're going to take the current batter that it figured out up on line 15. So the current batter, and we're going to concatenate to that a colon and a space. And then we're going to take the result, which is up on line 19, and concatenate that. And what I'm doing here is I'm using kind of like the old school concatenation approach. Now, and I just want you to be mindful of this. Concatenation means to join strings together. And when I take something that contains a number or a string, use the plus sign to join it with a string, use the plus sign to join it with another string, because that's what's going to be here, that will do the output, right? And it'll match what that little output screen shows. So that's one approach to doing this output. A different approach, and I'm going to comment this one out, and this is your choice which approach you want to use. There's no right or wrong here. And this is the one that most modern Python programmers are switching to. We call this the F-string approach, or the other name for it is interpolation, right? So right inside your print statement, you use the letter F, you put in your double quotes, and then you can use the names of the variables directly inside the string statement. So in other words, I could just say current batter, right, inside the curly brackets, a space, a colon, and maybe you don't want the space there. Maybe the colon should come right after the batter, then a space, and then we want to display the result. So I put that inside curly brackets too. So that's what I would call the more modern approach. There is a different approach too, right, that we learned, where you can take text, you do a comma, you put in the variable name, right? And then you don't have to worry about that extra space in there. That's one approach. And you also learn the formatting commands, where you can use the percent signs to drop in the wildcards. You guys remember any of that from Python? It's okay to say no if you don't, but you could Google that if you don't remember all the output approaches. But I think this approach, which we, a lot of Python programmers call it F-string for whatever reason, which means a formatted string. Technically, it's referred to as string interpolation, where the variable names can be directly dropped into the string statement as like words, but with the inside curly brackets. And I see more and more people switching to this approach in Python. And frankly, I think it's the easiest one to use and most flexible. So that's what I would recommend. All right, next, we start to ask questions. So if the outcome was 1, so in other words, they got a hit, right? We have to do a couple of things. First, we'll say hits per batter plus equals 1. You guys remember the plus equals thing? That's kind of the same as saying hits per batter plus 1. So you take whatever we had, add 1 to it, and store it back in, right? That's the same approach. It is considered a better approach, or easier approach, really, to do it this way. And experienced programmers never do it the other way, by the way. They pretty much only do it the plus 1 way. We'll do the same thing with total hits. Well, plus equals 1. So if they got a hit, hits per batter goes up by 1, total hits goes up by 1. Else if, or elif, you guys remember that? Right? That's how we do else if in Python. Pretty weird, but that's how it is. The outcome is equivalent to 2. Then the hits per batter, well, that's still a hit, right? A home run is still a hit. You would count that as a hit. So you would still plus equals 1 on the hits per batter, right? And the total home runs would plus equal 1. All right. Are there any other scenarios here that we want to keep track of? There is. What's the other scenario? That's if a stroke.
If an out.
right. And so how you choose to handle that, right? Like I could have started with zero, but I decided to focus on the positive. So we got a hit or we got a home run. I'm counting those right away. And I kind of didn't want to count the out. And I could, would it be logical to assume that if it's not a one or a two, it's going to be an out? So in other words, I guess what I'm saying is, would this work? I mean, in principle, it should work. All right. Another way to think of it, you could just put these two statements in there, right? And then have this as a separate if statement. So you could just say if outcome equals zero, outs plus equals one. But we know this random number generator is basically going to generate 0, 1, or 2 each time. So this is probably the most efficient approach right here. You could also have these all as standalone if statements. So I could say, if outcome equals 1, do that. If outcome equals 2, do that. If outcome equals 0, do that. That would be valid too. Is there a processing advantage to doing it this way? Okay, so here's where you guys have to start thinking, like, this is how like computer programmers think. They're like, well, that would have increased my efficiency of this statement by 33%, right? Because it doesn't have to check the last scenario. It's automatically that. See the thinking. All right. All right. So when we run this, once we reach 3 outs, we'll pop out of the while loop, and then we want to see the results of the while loop. So you notice I'm like backspacing here. And so now I'm coming back to one indent level inside this function. I want to be on this line, basically. So there I am. And now I'm just going to do some outputs. And just to kind of refresh your memory on how to do those outputs, right? With the other concatenation approach, here it is, right? The difference with this concatenation approach where we use the comma is it will drop this value in, but it also will add a space after that colon. If I wanted to switch it to an F string, which real frankly, I strongly suggest, you just put the letter F at the beginning, right? Total home runs, you would just cut that, remove the comma, put in the space you need, drop it into curly brackets, and that would give you the same result. So I think this is nice because you can see them side by side. But when you first learn Python, if you took it with me, at least, this is the approach we use to put stuff on the screen, right? But, you know, things change in Python since that book was printed, right? This was not an option in our book because it wasn't available in our book when it was printed. So there you go, right? So it shows you how the language evolves. But in the few short years that the book's been out, this has become the predominant approach for Python programmers. So I would suggest doing that. All right, this is the whole program. Let's do a Control S. I'm going to hit the run button here. So let's review all the code first. Here's the top part of the code. Screenshotters. 5, 4, 3, 2, 1. Scrolling. Right. You can always watch a video later too. And then the bottom part of the code. Right, here comes the run. And I think I got an error message here. Okay. All right, let's see if we can solve our errors. It says batter hit. Okay, great. It hit. And then it said here on line 37. Oh, okay. So I must have did something here. Yeah, line 25 and line 37 are my references. Now notice I didn't have any underlines in my code, so you guys are going to have to help me troubleshoot this mistake here. So line 25 puts me here. So let's see where we might have a problem. So hits per batter. So the loop basically ran, it got down to this point, and then something here broke it. Anybody spot what broke it? Yeah. George, I see you shaking your head. Thank you for at least reacting. Everybody else was like, I don't know, Ty, we're waiting for you to give us the answer. Right? Okay.
Is it the
Laura?
colon?
Yeah, I mean it's kind of saying something about a colon, isn't it? Type error, unsupported operand types for plus equals colon dictionary and int is what it's saying. Okay, can I give you guys a suggestion? Like
I think, sorry,
John?
I think, yeah, I think you are trying to add an integer one to hits per batter, which is a dictionary. Is I didn't
Thank you,
think
sir.
that was possible.
Yeah, it's not possible at all.
Okay,
Right. So
okay.
John's got the answer there, right? And okay, so this is kind of one of those goofy things I do as an instructor. Sometimes I walk us down a path, talk real confidently about like what I'm doing. You guys are all typing along and you're like, yes, this is going to work. Great. Thank you for doing my homework. But what would happen here? Like if you were doing this on your own and you got stuck here, what would you do? Because that error is like, I don't get it. Right. All right. But let's backwards engineer this. It's getting stuck here because this is hits per batter. What is hits per batter? Hits per batter is a dictionary. So if I want to add something to hits per batter, which dictionary item am I even adding it to? Remember, what I'm really building inside of here is a key with a batter name and a value. So I'm really looking for to add that one to whoever the current batter is. That's what's missing here. So I'm going to say current, let's get it spelled right, current batter. So which batter are we adding that to? The current batter, not the one that's not current. Okay. So that fixes that problem. But if I'm doing that here, I'm noticing there's another hits per batter here. So I better add that to that one too. Right? Yeah, totally. Now, total hits and total home runs doesn't matter because those are just regular variables. All right, let's try running it again. Great catch, by the way, John. All right, so now we have a complete simulation. So here's what happened when I ran it. So batter one hit, batter two home run, batter one came back up, he got a hit, batter two we got out, batter three hit, batter four out, batter two out. All right, we got three outs. It popped this out. We got three hits. Is that true? Yes. We got one home run. Is that true? Yes. Okay, so it worked. Now, every time you run this, because it's random, you should get different results. Sometimes it'll run longer, sometimes it won't run as long. But given the fact that it's a 1 in 3 chance to get an out, yeah. All right, so primitive, but that's the baseball game, folks. Let's move on to the next one. And we'll take a break after the next one if you guys don't mind. So I'm going to try to get through all these exercises. We're not doing very good with time here, are we? We're trying. All right, next one. Growth of an investment. And this one has us actually plotting some information. So this is actually kind of cool. So get the number of years, at least 5, from a user, and then display a histogram showing the distribution for money that doubles every year, begin with an initial balance of $1, right? This is a very classic programming problem. Like if you take, if you put a penny, if you were given a penny the first day and the second day you were given 2 pennies and, so on, it doubles every day. How long does it take before you have $1 million? It's not that long, by the way. It's like a month or something like that. It's a very short period of time. But that's kind of what we're doing here. So let's do a couple things here. So I'm going to go back to my code engine here. I'm creating a new file. Last time I called this investment, so let's call it investment.py. And I'm going to close my console here, and I'm going to start coding. Now, some of you may have had to do a little bit of research on this, and I'm hoping you did. Like, how do you make a bar chart in Python? Right, that should be a big one. There is this library in Python called matplotlib, right? That's the big library. So I'm going to just type it in. So we're going to import that library. It's called matplotlib, right? So that's the whole library. But I don't want really all of it, right? I just want the part that does the plotting. So this part, I would call this optional. So you could just say pyplot, right? So that's the tool within it that I want to use. And I'm going to alias it. So this is a new concept for you guys. Python programmers do this a lot. When they're importing a library, every time I want to use the pyplot, I would normally have to include this whole statement in my code. Cumbersome. But I want to alias it, so I'm just going to like shorten it down. Some people would just use one letter and call it P. I'm going to call it PLT, right? And this is an alias. So anywhere I would normally type this, I will now instead type that. So whenever you see that keyword as, it's creating an alias. At least that's how I call it. Maybe that's not the correct formal term for it. Next thing I'm going to do is I'm going to create a variable called years, and this is where I'm going to allow the user to type in how many years are we doing the investment, right? So I'm going to do an input prompt and just prompt it and say, enter a number of years. Like so, you know what? I want to convert this to an integer. I don't want them to type 3.75 years or something like that. I just want a whole number. So we'll put all of that input statement inside of an int. So we'll type it in, we'll type in a number, we'll convert it to an integer, and then move on. There is the possibility that they could type in letters here, so you could do a try catch or try except statement if you wish, but we're not going to do that here. All right. Now I'm going to create a couple of variables to hold lists, okay? And what I'm going to do here is I'm going to create these empty, and then I'm going to populate them with data that will get populated inside of a for loop. So I'm going to create two things here, and I apologize, I just typed on the wrong screen. So the first one I'm going to create is height list. So empty square brackets, sorry. And I'm going to have a list of all the string values too. So I'm going to call that a string list, also empty square brackets. So a list waiting to receive information. Then I'm going to run a for loop to do the investment calculation. So it's going to be a predetermined loop, right? So a for loop is really good when the loop is predetermined because I know how long it's going to run. I just have to let it run from whatever to the number that the user chose. I am, however, going to put in a value to start with because at a minimum it's going to be 1 year. So that's going to be my initial starting value. Then I'm going to write a for loop and I'm going to say for x in range. And what's the range? The range is the number of years the user typed in. So we're going to go up to that number, basically. Every time the user runs through that thing, their investment's going to double, right? So the first value that they're starting with $1, right? We're going to take that value and we're going to double it each time. So I could write this, right? Value times 2, right? That's one approach. Or, right, if you guys remember this, you can, like plus equals, we can do times equals, so I can double it each time. That's the same as doubling it. Right? Way more efficient way to write it. Then we're going to take that height list that we put together and we're going to append a value to it. So whatever value that was, I'm going to drop it in here. So that value is going to be doubling. So the first time through, it's going to be $2 and $4, right? And that's going to go into the list as a number, right? So the list is going to start looking like 2, 4, 6. I'm not doing it though, the loop is doing it. Right. The append statement adds it to the list. Then I'm also going to append to the string list, and the string list is basically going to be where we're going to hold like kind of the verbal description of what's happening. So you may have done this very differently, and that's quite all right. But I'm just going to say maybe something like year space, and then I'm going to append or concatenate. So I'm going to take string x minus 1. So what this does is it's going to take for each value in years. So in other words, every time we iterate through the number of years, so if the user typed in 10, we'll start with 1, we'll subtract 1 from it. So year 0, year 1, year 2, year 3, year 5. That's what it's going to do. But this value gets calculated, and then we turn it into a string so that we can concatenate it. You could F string this, and I'm just going to show you the way to switch it to an F string. Oops, is to put the letter F here, grab this, put it inside of curly brackets, and that's the same thing. And once again, modern Python programmers are switching to that approach, by the way. So you guys may as well latch on now. Okay, so that's going to go through, it's going to generate all the values stored in one list, generate all the year markers for the bottom of the bar chart in a separate list, and now we just have to plot it. So here's where it gets kind of fun. So we're going to learn about some of these libraries, so don't like freak out to this if you didn't get this at all. Copy mine. We're going to use the pyplot, and we're going to, because we're doing a bar chart here, there's an x-axis and a y-axis. So the x-axis is going to have a label. So we say x label, and this is just hard-coded text. And I'm going to put in year. That's what's going to go on the x-axis. Notice I use single quotes this time. Is that okay? Yeah, you can use single or double, doesn't matter. Then let's declare the y-axis. So I'm going to label the y. And this one's going to be called amount. So those are just labels by the bar chart. Now we want it to actually create the bars, but we need to feed it data, right? So this is where it gets kind of fun. So we'll still call the plot library. We'll tell it we want a bar chart, and then we're going to give it a range, right? So the range command is very often used in these scenarios, and it works just like it does in loops. So we'll have the starting point, which will be 1, and it's going to run up until what? It's going to look at the years that the user typed in. But remember how a range command works? You have to go one past the one that you want. So if the user typed in 10 years, I have to go from 1 to 11, right? So I would take the years that they typed in and add 1 to it. Remember that was like a really weird thing about Python range commands, where in other languages it stops at the number. All right, so that's what it's going to do there. And then right after that pink parenthesis, now we're going to tell it what its data source is. The data source is the height list. So it's going to pull the numbers out of there. And then that's the data for feeding the bar chart. So how tall should each bar be, basically? All right, there's a couple other things I'm going to throw in here, and I would call these optional, right? However, maybe this one's not quite so optional, I think. But whenever you do a bar chart on the x-axis or the bottom, there's the little markers, like how are you going to mark each year? Well, that's the whole point of the string list, by the way. So we call that a tick, actually. So the x ticks, right, are also going to use a range. And those are going to go starting at 1, once again up to years plus 1. And then what data are we feeding that? So these are the markers at the bottom, and it's going to be the string list that we developed. So what's it going to say? Year 1, year 2, year 5, year 10, whatever. And, all right. So the grand command to make this all run at the end is you just say that plot library thing, show it, is how you do it. However, I'm also going to do this other thing that I would also say is optional, but I think it's a good plan, which is to scale it, or basically show the little log that goes with it. So if you guys want to follow that. So that basically shows how high that bar. So if you look at the example here, it's better to look at a picture, right? This is the scale. These are the ticks. This is a label. That's a label. Right. The coloring, by the way, is automatically random. Although you can, if you really dig into these libraries, you can specify all of that stuff. But sometimes it's better to let it just kind of happen automatically. So we're going to get a combination of text output and then a graphic when we run this. So let's save it. Right there it all is. And we're going to hit the run button. I do see a yellow underline there, so I'm a little concerned about that. All right, so it's not finding my matplot library. So this is not in the standard libraries that I need in this tool. If you are inside of Jupyter Notebook, this worked. If you're inside of Spider, this worked. Can anybody confirm? Yes, it does work. All right. Notice here in this product, because I've never done this in this product before, it says import could not be resolved from the source. All right. And notice that this tool offers, and this, a lot of Microsoft products do this, they have a quick fix. Okay, ignore it. So it's like different to learn more about resolve. So basically, I have to learn how to resolve this. So here's how I'm going to solve this. I'm just going to bring up Spider right now, and I'm going to run it in Spider, and I'll show you that it works, and then we'll just move on. The reason that it works in Spider is because all those libraries are part of the Anaconda distribution. The libraries are automatically included. When they're not included, then you have to build the libraries into your project folder, which doesn't happen automatically in other IDEs. And these are just all things that you have to kind of learn. The important thing is you don't freak out to any of it, right? All right, and I'm just going to use this temporary file here, and I'm going to copy all of my code. So I'm going to do a Control A, Control C, paste it in here. I'll zoom in so you can see it. And then we'll just do a run just as it sits, and you can see in the console already that it's running, so no problems with the library. So we're going to say enter the number of years, and I'm going to say 10. All right. You guys notice what the output says here? Okay, so where's my bar chart? To make them
It
also
should be
appear
up
in
on
line in the
top.
console. Yeah, right. So here's the use for that other panel. So notice this little thing that says plots right here. There's my bar chart. Pretty slick. Yeah. Now mine did not alternate color code. I'm not sure why, but you know what? It still looks pretty good. I'm pretty happy with the overall result. I could also have run this inside of Jupyter Notebook. Did anybody try it there? Anybody? Nobody? Okay. But you'll notice the output, and this is a very primitive example of how these tools work, but the output's pretty nice looking, right? And some of these libraries generate really beautiful graphics, by the way. Right. And we're not even doing GUI programming yet. This is stuff that's, you know, been developed for quite a while. So this is Matplot library. We are going to take a really quick little break. Let's try to make it like a short break, like 3 or 4 minutes, and then we'll come back and kick in on the coding. I am going to pause the video. All right, we're back from the break and we're going to work on the next exercise. This one should go fairly quick.